Okay, so we're going to go ahead and look at this year. This is basically 2024, but we're going to look at this year's review. I guess the one I had posted was for a different review from a few years ago, where I covered a little bit different material that particular time around. So here we go. So we'll start off with just a little bit of conversion between forms. So when we start this, again, this is not a requirement, but for me, I've always felt like it's really super helpful if we can actually have a picture. So when we look at this particular problem, and I've noticed an awful lot of you are wanting to resist that idea of always starting with an axis. I always start with an axis every single time. So I always start with an axis. But if I were to go to the left 8 roots of 3 and up 8, this is one of those problems where we could do the Pythagorean theorem to find that radius, but we should actually recognize that if you have a number and that number root 3, then that should make a hypotenuse of 16. So if we're looking for an r and a theta, my r should be 16. Now, again, it could be considered negative 16, but I usually just keep it as a positive. And then what I like to do is I like to look at an easy ratio. And I happen to know that if the sine is a half, anytime you have a sine that is 1/2, then our reference angle is going to be some kind of a pi over 6. And so notice the opposite of our hypotenuse. So that's going to be some kind of a pi over 6. But in order to put it in the second quadrant, it would have to be 5 pi over 6. Because remember, this quadrant would be 1 pi over 6. This is 5. This one down here is 7. And the last one is 11. And since it's in the second quadrant, I'm picking 5. Now, that being stated, I would also really encourage you to do something like this. See, if I have done this right, we know that the x value is r cosine theta. So look, r cosine theta. So let's try something out, r cosine theta. Well, when I did r cosine theta, I got this number right here. And it should be negative 8 roots of 3. And see, I can see that that number, in fact, is perfectly correct, okay? Now, similarly, right here, if you go to the right 7 and down 7, that's going to make a hypotenuse of 7 root 2. That's, again, another little special right triangle. So 7 roots of 2, again, would be my radius. And then I have to come up with my angle. But because it's isosceles, it has to be some kind of a pi over 4. Now, one of the characteristics of polar that is kind of new is that there isn't one answer for things. There's an infinite number of answers of things. So it would be perfectly fine if you decided to rotate down and call it negative pi over 4, but you could equivalently call this thing 7 pi over 4 or even 15 pi over 4. There's all sorts of names. So keeping going a little bit, if you went negative 3 and negative 8, the Pythagorean theorem would be 9 and 64 make 73. So my radius is root 73. Now, the theta part is a little bit trickier. So you have a couple of ways to do that. Now, if I tried an inverse tangent, because that would be opposite over adjacent, and I tried negative 8 over negative 3, and if I know I could do 8/3. But if I do that, you're going to notice it's going to say 1.2 radians. It's going to think that it's up here. And that's okay if you add pi to that answer. That would rotate it down here, or 4.356. You have that as a possibility. Or if you wanted to, we could go to our angle number 6 and ask the calculator what happens when you go from rectangular to polar and look for that. Now you'll notice I don't have quite that same answer, but remember coterminal angles could add a full circle, and a full circle is 2 pi radians, and we have that. Now, if you chose to do this in degrees, that's not an issue. I don't mind answering this in degrees as well. See, if I went back and I did RP theta, I'd have negative 110 degrees, or again, adding 360. You could either call this 110.556 degrees, or you could call it 249.44 444 degrees. Cool. And that's good too, you know, if you wanted to go that way. Now, that's what happens if you're dealing with coordinates. Now, equations, I'm going to go ahead and stop this and pause this for a second for the video. All right, now the music is over, we'll go back to the next couple of problems. Okay, so question number 4. Instead of taking a coordinate set, let's do an equation. So remember, we have a fancy little set that says x is r cosine theta and y is r sine theta. So to convert something from rectangular to polar, that's the first thing, is we just literally just do a substitution of our equations, but we'd really like to get r sitting by itself. So if we were to factor r out, we would be sitting here, and therefore to get r by itself, all we need to do is to divide by this quantity underneath. So we're done. Number 4, easy peasy. Now, of course, it's not a bad idea, because you could graph this and you could graph that and see if in fact it actually makes sense, if you actually got the value you wanted. Now, number 5 was just like a little foreshadowing question because it was x squared. So that would be r squared cosine squared plus 2r squared sine squared equals 9, which is great, but I don't want to factor r out. I'm going to factor r squared out. And I put this in fact, because I know it's tempting for people to want to convert that cosine squared plus sine squared to be 1. But we don't want to do that because it's not cosine squared, it's plus 2 sine squared. That 2 makes a difference. And so all I would have left is I would say that r squared is 9 over cosine squared plus 2 sine squareds. And it turns out, a little foreshadowing, this is actually going to be the equation of an ellipse. So it's going to be sort of an elongated looking circle. And last is number 6, is we have this circle centered at -2, 4. Up here with a radius is root 20. So we'll see what happens. So if now we could actually substitute early like I did right here, but I generally find it a little bit easier if you multiply things out a little bit first, do a little canceling, and then things get easier very quickly. So I'm going to start off by saying x squared plus 4x plus 4 plus y squared minus 8y plus 16 is 20. So I just distributed this one out and this one out. I finished all of that. But one thing that you'll notice right away is the 4 and the 16 add up to 20. So that all cancels out. And now we have this little story, which is you've got x squared plus y squared plus 4x minus 8y, and all of that's equal to 0. Well, we're now ready to go because I know that x squared plus y squared is r squared. Cool. And I know that x is r cosine theta, as I used over here, and that y is r sine theta. But now I have an equation set equal to 0, and I want to get r by itself. But if I go ahead and factor that r out, I would be left with r times r is r squared, r times 4 cosine theta, and r times this. And so again, zero product property says one of these two values, because r is being multiplied by this. So this is my product. So either r is 0, which is sort of a silly answer. We know it's a full circle, not just a point. Or r must be -4 cosine of theta plus 8 sine theta. And again, that -4 is going to pull it to the left, and that plus 8 is going to push it up. And there we go. The first 6 questions are down. Okay, I'll see you guys back in class. Bye-bye.